I'm Professor Burns.
Hi, I'm Professor Burns.
Hi, I'm Professor Burns.
This is the brick that we'll be measuring today.
Hi, I'm the brick. Alright, Professor Burns, today we will be conducting the Modulus of Rupture test on the brick we see here, according to ASTM C67. But before we can begin, we have to take a few measurements of the brick. First, we must measure the length of the brick. 7 1/4 inches.
Yes, Professor Burns, 7 1/4 inches.
Alright, Professor Burns, now we have to figure out where we're going to set it on the machine at.
You're good.
I'll just keep going. We have to measure 1/2 inch in from each side, so do we have a marker? Let's mark this. Alright, now our measurements are complete. Alright, most of the time the brick breaks almost directly in the center, so we are going to measure where the center is using 1/2 of this total length, and we will put a mark on it.
Now, Professor Burns, we'll load this on the machine. Place the lines directly above these beams and use this steel member for where the point load should be, and we will now run the test.
Split me in half, Professor Burns.
We're gonna brick, we're gonna split you in half.
Here's our plane of failure along our brick. Now let's take it out of the machine.
Here you go, Professor Burns.
Alright, Professor Burns, now we're going to calculate the modulus of rupture.
Can we see the, that's where our brick is broken.
Alright, Professor Burns, now we're going to calculate the modulus of rupture for our brick using this equation according to ASTM C67. Where P was the load of failure, L was the span length from the 1/2 inch line to the 1/2 inch line, the X was the distance from the plane of fracture to the midpoint of the brick, B was the thickness of the brick, and D is the net width of the brick, not including the hole.